Hello and welcome to this FMSP online revision session, looking at the Edexcel FP2 specification. This revision session is looking at polar coordinates, and we'll be looking at these sections of the specification: the use of polar coordinates of the form r theta, and the use of this formula for finding areas. Note that this formula is in the formula book, so that means first of all that you don't need to learn it, and secondly that there are no excuses if you copy it incorrectly, so do take care with that. A few key points and then we'll have a look at an examination question. First of all, it is helpful to have a graphical calculator in case they ask you to sketch the curve. However, it does seem that exam boards are aware that some students have a graphical calculator and some students don't, and I haven't actually seen a question asking you to sketch a curve for some while. If you are asked to sketch a curve and you want to check it on your graphical calculator, they will almost always include a parameter, and if you want to use your graphical calculator you will need to put in a value for that parameter as an example. Do avoid using 0 or 1 because you'll miss some key points, and do think very carefully about how changing that parameter will change your curve. You need to check any intersection points carefully. Often you'll be asked to find those. And do take care with the limits of your integral, which you will get either from the information in the question or you will have been asked to find those points of intersection first. The other thing that you need to be aware of is how to find maximum and minimum values, not just of r by doing dr by d theta and setting that equal to 0, but also looking for maximum and minimum values of x and y. So from this diagram here, you'll note that x is equal to r cos theta and y is equal to r sin theta, and you can use those then to find dy by d theta by substituting in y, and dx by d theta by substituting in for the value of x. You then continue to find your value of theta in the usual way. So let's have a look at an exam question. It's very important that you read through the question carefully first, and with these questions, particularly where you have more than one curve, it's very important to identify which curve is which to start with. So if I call this one curve A, it's just r equals 2, which is a circle, and they've labelled it up there. Let's label that with a nice big A. And the second one here is B. That will come in useful later. You're given that the angles are between 0 and pi over 2. So you're shown the whole of the bit that we're interested in. The first part of the question is asking for the points of intersection. That's this point here and this point here. And then the region S between the two curves, where r is bigger than 2 and less than 1.5 plus sine 3 theta, shaded there. You're asked to find that area by integration. Well, there isn't any other sensible way of doing it. You're told your answer will come in this form here, so a multiple of pi plus a multiple of root 3. And in order to get full marks, you will need to make sure that you have written a and b as simplified fractions. Okay, let's start the question looking at the points of intersection. So at the points of intersection, the value of r is the same for both. So we can say that 1.5 plus sine 3 theta is equal to 2. So sine 3 theta is equal to 1/2, and either from your calculator or because you know the result, 3 theta is pi over 6. A quick sketch will show us where to find the other solution. That is pi and 2 pi. If I've got one value here, the other one is there, so by symmetry I need to take that pi by 6 away from pi, giving me 5/6 pi. Dividing by 3, that gives me the two values pi over 18 and 5 pi over 18, and therefore the points of intersection are, the value of r is 2 in both cases, 2 pi over 18 and 2 5 pi over 18. Okay, just looking at the diagram, I need values between 0 and pi over 2, and I've got values between 0 and pi over 2. Very simple check that's worth doing. Okay, the next thing is to find the area. So we need to look at sectors. So I've now got a sort of ice cream cone shape. And what I need to do to find the shaded area S is to find the whole of that area I've just drawn and then subtract the sector of the circle. So if we go for the whole ice cream, that is the integral, copying the formula from the first page, from the formula book, a half r squared d theta between our limits of pi over 18 and 5 pi over 18. And then very carefully substituting in the formulae from the question. We're doing the whole cone, so we're looking at the outer curve, which we labelled B, and that is 1.5 plus sine 3 theta all squared d theta. So a half pi over 18 to 5 pi over 18. I need to square that, so that's 1.5, that's 3 over 2 squared is 9 over 4, plus 2 lots of 1.5 sine 3 theta is 3 sine 3 theta, plus sine squared 3 theta. And of course you can put in an extra line of working if you are not confident with doing that in one step. So that's a half pi over 18, 5 pi over 18. I can't integrate sine squared, so I need to rearrange it. So a little bit of side working here. I remember this version of the cos 2 theta formula and work out everything else from that. Saves having to memorise so many formulae, but do feel free to memorise all the versions of this if you prefer. I need a formula in terms of sine squared, so I need to get rid of the cos squared, which is 1 minus sine squared. So that's 1 minus 2 sine squared theta, and therefore sine squared theta is equal to a half 1 minus cos 2 theta. Now I've got sine squared 3 theta, and therefore that must be equal to a half 1 minus cos 6 theta. So I'll now substitute that in. 9 over 4 plus 3 sine 3 theta plus a half 1 minus cos 6 theta d theta. And simplifying that, so collecting these two terms together, 9 over 4 plus a half is 11 over 4 plus 3 sine 3 theta minus a half cos 6 theta. Okay, I need a bit more space, so we just had from the previous page, this is the integral we're trying to do. Okay, integral of 11 over 4 is 11 over 4 theta. Integral of sine 3 theta is cos 3 theta. Just check that. If I differentiate, sorry, minus cos 3 theta. If I differentiate that, I'll get 3 sine 3 theta minus 3 sine 3 theta, and I want plus 3 sine 3 theta, so I need the minus sign in there. Integrating cos gives me sine, so that will be sine 6 theta If I differentiate that, I'd get 6 cos 6 theta, and I only want a half, so I need minus 1/12 in there. And I'm evaluating that between pi over 18 and 5 pi over 18. Okay, so that's a half. If I substitute in 5 pi over 18 times 11 over 4, that's 55 over 72 pi, minus cos of 5 pi by 6 on the calculator if necessary, root 3 over 2. And if I put in 6 lots of 5 pi over 18 sine theta and divide it by 12, all on the calculator, get root 3 over 24. Then substitute in pi over 18. 11 over 4 times pi over 18 is 11 over 72 pi. Cos of pi over 6 is minus root 3 over 2. And putting in pi over 18 into the sine 6 pi, all divided by 12, gives me another minus root 3 over 2. Collecting everything together gives me 11 pi over 36 and 13 root 3 over 24. So I've got everything in the right form, and doing it on a calculator means that everything is already simplified. So that's the area of the whole ice cream cone. So if I now do the sector of the circle, the angle is 5 pi over 18 minus pi over 18, which is 4 pi over 18, or 2 pi over 9. So this is 1/9 of a circle with radius 2, and its area is therefore pi times 2 squared divided by 9, which is 4 pi over 9. No point in messing around with integration for that bit. The required area S is therefore 11 pi over 36 plus 13 root 3 over 24. Take away 4 pi over 9, which comes out to be 13 root 3 over 24 minus 5 pi over 36, which is written as a multiple of root 3 and a multiple of pi as required. So let's have a quick look at how the mark scheme works for this question. So going back to part A, there is a method mark and an accuracy mark for finding the two values of theta, and an accuracy mark for dividing those by 3 to give the correct angles, and then of course noting the points of intersection are 2 and then the two angles. For part B, there is one method mark for substituting into the given formula in the formula book. There is another method mark for using a double angle formula to get rid of your sine squared, and another method mark for integrating that. There is a method mark and an accuracy mark for finding the area of the sector of the circle, and a final method mark for subtracting that from whatever you got for your integral, and a final accuracy mark for actually ending up with the correct answer. Okay, well that's all you need to know for polar coordinates. I would like to wish you all the best with your preparation for this exam, and look forward to your company in some of the other revision videos for this specification. Goodbye.